We can stop HIV, Iowa.
A person living with and being treated for HIV can take one pill a day to protect their own health and prevent HIV from passing to sexual partners.
We call it U equals U. Undetectable equals untransmittable.
Visit StopHIVIowa.org.
Hello and welcome. This is a brand new podcast. It's called Astronomy Daily. My name is Andrew Dunkley and I'm your host. Thanks for joining me. Now, for those who listen to the Space Nuts podcast with Professor Fred Watson, you would know who I am. I'm the co-host of the show with Fred. We've been running the Space Nuts podcast for, to be coming up on 6 years now, I suppose, 5 or 6 years. And we have a really good following and a great group of listeners who tune in every week. So you can tell I work in radio, tune in, who log in every week to listen to the podcast. And we thought it would be a good idea to kind of expand on that and create a daily short form podcast, and that will be this one called Astronomy Daily. So we'll be bringing you news from around the world in astronomy and space science. So I hope you'll enjoy that. Bite-sized pieces, if you like. For those who don't know me, I am a radio broadcaster / journalist. I've worked for the Australian Broadcasting Corporation. I've worked in commercial radio and more recently working in community public radio, as well as doing the podcast with Fred. On top of that, I'm an author. I love writing science fiction. I've also written books about the First World War. My grandfather fought on the Western Front, so I wrote his story. And I've written a couple of tongue-in-cheek books, one about losing your temper on the golf course called 5 Irons Don't Float. And more recently, I've been sort of doing a diarised rundown of how things have been developing since the beginning of the COVID-19 outbreak, called the COVID-19 Experience. So you can look all those up online under my name or go to my website if you're interested, andrewdunkley.com, but we'll just leave that there. That's up to you. But this podcast is all about astronomy and space science, one of my great passions, and I'm very, very lucky to have been working for 25 plus years with the likes of Professor Fred Watson on radio and more recently on the Space Nuts podcast. But I'll have Fred on here from time to time, but my co-host, if you like, with this particular podcast is Halley. Halley is an artificial intelligence robot, and she is joining me now. Hi, Halley. Welcome.
Hi, Andrew. I'm looking forward to working with you, but I have been warned about your terrible dad jokes.
Oh, gee, thanks. I don't know who you've been talking to, but there can only be a couple of suspects. But that's not how I wanted to start the relationship, Halley.
Well, I haven't heard any yet, so I'll reserve judgment.
All right, well, I've got one for you. I know what AI stands for.
Oh, what's that?
Artificial insults.
I think I was accurately informed.
Yeah, I'm thinking that too.
The Astronomy Daily Podcast
with Andrew Dunkley.
Anyway, Halley, your job is to provide us with news in astronomy and space science with headlines, so have at it.
China is planning to construct a new telescope array to study the sun. It will be the world's largest array and will, hopefully, help us to better understand the effects of coronal mass ejections on our planet. The Daocheng Solar Radio Telescope is currently being built in southwest China, and when it's done will be made up of 313 6-meter dishes. All up the telescope will have a diameter of just over 3 kilometers. That's around 2 miles for the people who use that age-old imperial unit of measure. Astronomers have been observing carbon monoxide deposits in planetary systems for a very long time. Its a compound is ultra-bright and extremely common in protoplanetary disks, so it's a popular area of study. But something's amiss with the observations. Light, really, a massive amount of carbon monoxide, that should also be there, is missing. Now, a new model of protoplanetary disk study has found the problem. It seems the carbon monoxide has been playing cat and mouse and is hiding in ice formations. The discovery has been published in the journal Nature Astronomy. NASA has released the sound of a black hole, which has been described as terrifying. Here's a sample. The black hole is about 200 light-years away in the Perseus galaxy cluster. The sound was recorded using the Chandra X-ray Observatory. The audio recording is said to be 57 octaves below middle C, and Andrew? Those are the headlines.
Okay, thank you, Halley. We're off to a flying start. That certainly was creepy, wasn't it? Sounded like something from a horror movie. To other events happening in astronomy and space science, and NASA's historic Artemis 1 mission will launch towards the moon in just under a week if all goes to plan. Artemis 1 is a test flight. It's an unmanned mission, which is designed to keep the costs low for the first test. It will use leftover Orion crew modules from previous missions that were successfully recovered by a US Navy ship. The Artemis missions will ultimately send humans back to the moon as soon as 2024, including the first woman on the moon, they hope. Now, hitching a ride on NASA's Artemis 1 is a CubeSat weather station designed to orbit the sun in interplanetary space. The satellite will take the first ever readings of solar wind from the sun's north and south poles and measure how conditions change over time. Oh, and interestingly enough, Chris Evans, the co-host of the Marvel Cinematic Universe, and Jack Black, the famous actor and director, will make special appearances during the live broadcast of NASA's Artemis 1 launch from Cape Canaveral. And you can watch the live launch starting at 8:30 a.m. August 29th, that's US Eastern Daylight Time, on NASA TV. Now, Jupiter is one of the most active worlds in our system, and the effects of its powerful magnetic field can be seen across the entire planet, from creating strange cloud shapes near the poles to influencing auroras hundreds of thousands of kilometres away. New images that have been taken by the James Webb Space Telescope's NIRCam flight camera in infrared light have captured Jupiter's auroras along two different axes, at the North Pole and along the arbitrary line passing through the southern hemisphere. Both grayscale images were assembled by making a mosaic of many different individual images. The auroral images were obtained by blocking out light from other parts of the planet, so features close to the surface are more easily seen. Now, the effect makes it seem like we're taking a light-focused tour just above the planet's poles, looking down at the auroras in the belts around the planet. Auroras are formed when charged particles in space are accelerated towards a planet by its magnetic field. It's a stunning series of images, well worth looking up online if you get the opportunity. The James Webb Space Telescope is proving very, very exciting and will certainly set new benchmarks in astronomy and space science investigation. And a team of cosmochemists, they're called, has analysed the pebbles which were collected from the Ryugu asteroid by the Hayabusa spacecraft, and it's revealed their chemical and mineralogical compositions. The samples were returned to Earth in 2020, and the team analysing the samples revealed their findings in a new paper, which was published in Science Advances. The paper's lead author is Haruka Kodama, scientist with the Tokyo Institute of Technology. Kodama said in an interview with New Scientist, "This natural laboratory that Hayabusa 2 has provided is a great opportunity for us to see the solar system's early days up close. We've already obtained a lot of valuable information from the relatively small number of pebbles, and we hope to conduct further analysis on more pebbles and learn more about the early history of our solar system."
The Astronomy Daily Podcast with Andrew Dunkley.
A new way of looking at exoplanets has been proposed. At least in principle, it has the potential to detect more worlds. It would also allow us to study features of individual planets that we cannot observe any other way. The new method is based on observing radio emissions from a planet's sun instead of the light that it gives off. The transit method is a powerful tool, but it has limitations, not the least of which is that the planet must pass between us and the star for us to detect it. Sometimes that can take hundreds of years, sometimes not at all. The transit method also relies on optical telescopes. Radio telescopes, however, can detect planets that are far enough away from their stars that they're heated by them, the same effect that causes stars to form into red giants as they age. The proposed method completely bypasses all these limitations. The European Space Agency is seriously considering developing space-based solar power to increase its energy independence and reduce greenhouse gas emissions. Pilot projects may be in the works to test how feasible the technology is, and countries like France, Japan, India and China are planning to build their own solar power satellites. The idea of solar power in space isn't new. Scientists have been studying it for decades, and it was initially deemed feasible for providing energy to Earth. But nothing was developed due to the high cost of installation and a related drop in efficiency. But now, with advancements in technology, the cost of launching a solar power satellite has plummeted. Space-based solar power would allow us to bring renewable energy anywhere on the planet where there's an area capable of supporting panels. With space-based solar power, some countries could get more energy than they need, giving them an energy advantage over other nations. Earth's surface still bears the scars of the gigantic asteroid impact that wiped out the dinosaurs, almost 3/4 of life on Earth on top of that. But a new study suggests the killer rock wasn't alone. The research suggests that a second, even larger impactor hit the Earth around 300,000 years before the dinosaurs died. This second impactor also left a crater that is yet to be found, though its existence is strongly suspected from its effects on Earth's climate. Because the two impacts occurred within 250,000 years of each other, their effects were likely to have been additive and were probably responsible for extinguishing the dinosaurs and many other species. Details of the new work by Sean Gulick of the University of Texas were presented to the American Geophysical Union in San Francisco. And finally, how many moons too many? A team of researchers from the University of Texas at Arlington, Valdosta State University, Georgia Institute of Technology and the National Radio Astronomy Observatory estimated how many moons could theoretically orbit the Earth while maintaining present conditions such as orbital stability, and the answer is about 2 or 3. But we could maintain up to 12. That said, as many as 5,000 moons are possible, at least in theory, and who knows what life would be like under those kinds of circumstances. Well, that just about wraps it up for our very first episode of Astronomy Daily. I hope you enjoyed it. Hayley, anything more you'd like to add before we wrap it up?
Yes, Andrew. If you want to find out more about the stories from today's podcast, visit spacenuts.com and click on the Astronomy Daily tab. And while you're there, listen to the Space Nuts podcast with Andrew and Professor Fred Watson. A new episode is coming very soon.
Episode? Sounds like I need to tweak your software, Hayley. Oh, and while you're on the Space Nuts website, don't forget to subscribe to Astronomy Daily. It's absolutely free. Well, that's it. Thanks for your company. This is Andrew Dunkley for Astronomy Daily. We'll catch you next time.
The Astronomy Daily Podcast
with Andrew Dunkley.